Hello everyone. I want to start by saying thanks to all involved in this course. This has been a truly amazing experience. My project is called EdSmith, and the tools and techniques used here are close enough to what I use in my job that I opted not to share the code directly. However, I pulled it up here so that I can showcase parts of it through this video. So this is a multi-agent system that augments student essay data to give generative feedback to student test takers. The system is designed to also incorporate that generative feedback as fine-tuned reasoning to create a model that can both grade student responses and provide personalized information back to the student. At the core of this project is the EdSmith agent that orchestrates everything. And this is currently controlled by Cloud Code and is defined via an agent and associated scale markdown file. There are two MCP servers. The first one is for EdSmith itself, and the second one is for Google Colab, which allows the Agentic system to autonomously test out variations for fine-tuned experiments. The augmented data is produced by an agent called the examiner, and this is configured to run via OpenRouter and has a number of tools at its disposal. The tools it has available are assigned by a third agent called the chief examiner, which analyzes the results from fine-tuning experiments and has the ability to dictate how the generative feedback is created to optimize those fine-tuned models. So this system works by first initializing a session, and then the run examiner pass runs and updates the data. It stores it in this EdSmith drive, and the model training gets kicked off, and then the run chief examiner runs, and then a human reviews the decisions made by the run chief examiner, and then it either accepts it or rejects it, and then it goes back to the chief examiner. And so this can run in multiple iterations, ideally to over the course of a session to get better and better results. Okay, so the session YAML is what sets all of this up. So we designate the models to use for the subagents, and then information around the prompt policies. So this is what the examiner would incorporate into how it generates the feedback for the student. And then we have some sampling information that we can incorporate. So the initial data set is about 10,000 records. Running through all that takes quite a long time, so I just have it set to 3,000, which is enough to give us information that can be learned by the fine-tuned experiments. And then the strategy guidance indicates like the tools and which ones are available and which ones should be set for the examiner to use, so that chief examiner can update these as it sees fit. And then the scorer is how the fine-tuned model gets set up. So it has the hyperparameters, which component of the rubric is actually getting fine-tuned against, and then which model to use for fine-tuning. Okay, with that, I'm going to kick this all off. We'll open a cloud session, and I'm going to say init session and run examiner pass. Okay, so it's going to think a little bit, and so we have this shared EdSmith drive space. So this saves things locally, and then that also gets synced to Google Drive. And so the Google Colab MCP server can interact with the EdSmith MCP server, and they can share information through this folder. Okay, so just created this one. We got the test and validation and training split. So as we iterate through different updates through the session, we want to make sure we're using the same data splits, so we're not, seeing lift due to some random chance of, an artifact of how we're splitting the data. Okay, so now I'm going to go over to OpenRouter, and we can take a look at what some of these API calls look like. So it doesn't look like they've started to get kicked off for this session yet. Actually, take that back. Looks like they're just starting to run some of their tool calls. So in the interest of time here, I'm just going to go to some of the ones from a previous session from a few minutes ago. Actually, go to a more interesting one that actually has some tool calls here. Okay, so we have our system prompt that tells the LLM that you're grading student responses, the level of specificity for how it's going to generate its feedback, the rubric, and how to differentiate the different scores. As we saw in that session file, if it's supposed to cite the examples or not. So here it's supposed to cite evidence from the rubric for why it's giving the grade it is. And then it defines the tools that are available for it to use, and then the structure of how it's expected to complete the output. And then for this data set, there's only an overall score, but there's multiple components to the rubrics. So for this, the idea is that we can calibrate these scores to the overall score and have, along with the generative feedback, the examiner also give what it thinks the component score should be based on the tools it's calling and the rubrics and all that stuff. So then we have the actual user prompt. So this has the question that the student has asked, the essay they wrote, and then again for calibration, the overall band score. Here we can see that there is 2 tool calls made successfully. So we have a grammar check and then aggregated age of acquisition stats. So here we can see, let's see, so it looks like they misspelled possible or possibly, and then it looks like they had a wrong participle. Participate. So okay, they're saying having a different tense of that word, I guess, or something. And so then there's age of acquisition stats for the grammatical errors that they're making. So the idea there is that, if they're messing up more sophisticated words, that probably should be penalized less than if they're messing up basic English. Okay, and so then we can see the results here. So it's following the expected format nicely. Let's see. Okay, nice. So it's incorporating some of this age of acquisition stuff. So the intersection between the grammar errors and the age of acquisition stats can be quite powerful in automated assessment. So it's quite interesting that it's actually picking that up and incorporating it into its overall feedback. So just in general, I've been very impressed with Qwen 3.5, given the fact that this is only a 9 billion parameter model. It is very good at picking up the skills and kind of wrapping everything up across the rubric and everything into a cohesive statement back to the student. All right, so with that, I'm going to switch over. So as I mentioned, the actual examiner pass can take quite a while. So we're not going to sit through all of that. But once that examiner pass had finished, the EdSmith would kick off this Google Colab MCP server session, and it would load in all of this code, and it would start training the model. So here I finished one of these not too long ago, and you can see the losses going down quite nicely. And then I just have an example here of an input. So this is a real student, the question and their actual answer, and you can see that the model successfully learned the expected pattern for what it's supposed to put in this thinking tag, and then also the overall score itself. And so the nice thing is, you could disable this, the quality of the scoring would go down inevitably, but yeah, it's very impressive that it was able to figure all this out and that all this stuff came together in the end. So that's it for me. I'm very close to being at time, so appreciate everything everybody's done in this course, and take care.